Preparing for a database administration at MUFG interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a highly available database platform for a critical MUFG banking application? I would begin with business requirements, transaction volume, RPO, RTO, and acceptable downtime. For critical workloads, I would use clustered primary databases with synchronous replication within a region and asynchronous replication to a separate disaster recovery site. Automated failover needs quorum, fencing, and application connection recovery to avoid split brain. I would test failover regularly, monitor replication lag, and document manual fallback procedures. The design must balance strong consistency, operational complexity, and recovery speed. While answering, cover synchronous and asynchronous replication, clustering, automatic failover, recovery objectives, split brain prevention, health checks, transaction consistency, planned maintenance, and regional disaster recovery considerations. Question 2. Explain your approach to database backup and recovery for a regulated banking environment. My backup strategy combines periodic full backups, frequent incremental backups, and continuous transaction log archiving. I encrypt data in transit and at rest, store copies in separate failure domains, and use immutable retention for protection against ransomware. Backups are only useful if recoverable, so I schedule restore tests, verify checksums, measure RTO, and document results. I also align retention and access controls with regulatory requirements, legal holds, and the application's RPO. Make sure to cover full, incremental, and transaction log backups, encryption, retention, immutable storage, offsite copies, point-in-time recovery, restore testing, recovery objectives, and audit evidence. Question 3. A production database suddenly shows high CPU and increasing transaction latency. How would you investigate? I would first confirm the alert and compare CPU, latency, throughput, locks, memory, and I/O against the normal baseline. Then I would identify the busiest queries, current wait events, blocking sessions, and execution plan changes. I would check recent releases, statistics refreshes, and data volume changes. Immediate containment might include throttling a batch job or safely terminating a runaway session. After stabilizing service, I would tune the root cause and record evidence for a post-incident review. In your answer, talk about alert validation, workload baselines, wait events, blocking, execution plans, recent deployments, resource saturation, query statistics, containment, and evidence-preserving remediation. Question 4. What is your process for diagnosing blocking locks and deadlocks? Blocking means one transaction holds a lock another needs, while a deadlock forms a cycle where transactions wait on each other. I inspect lock monitoring views, transaction age, waiters, blockers, and deadlock graphs. I then identify long transactions, missing indexes, inconsistent table access order, or excessive isolation. Short-term action may be killing a safe blocker after impact assessment. Long-term, I reduce transaction scope, standardize access order, improve indexing, and add bounded application retries. Be sure to mention lock modes, transaction duration, wait graphs, deadlock logs, consistent access order, indexing, isolation levels, retry logic, and coordination with application developers. Question 5. How would you improve a slow SQL query without creating operational risk? I start with the actual execution plan and measured runtime, not assumptions. I check whether predicates are sargeable, estimates match reality, joins use suitable indexes, and statistics are current. I compare alternative indexes or query rewrites in a representative environment, measuring CPU, I/O, concurrency, and write overhead. Before production, I use a controlled change with monitoring and rollback. An index that speeds one query but harms inserts or storage is not automatically a good solution. Focus on execution plans, cardinality estimates, indexing, sargability, statistics, joins, bind variables, regression testing, workload impact, rollback planning, and controlled production deployment. Question 6. How do you plan and execute database schema changes on a live banking system? I prefer an expand and contract approach. First, I add backward-compatible columns, tables, or indexes, then deploy application code that can handle both versions. I backfill in throttled batches, validate counts and checksums, switch reads or writes gradually, and remove obsolete structures only after observation. I assess DDL locking and transaction log growth, test rollback, obtain change approval, and schedule high-risk work outside peak processing. For regulated systems, I retain implementation and validation evidence. In your answer, cover backward compatibility, expand and contract migrations, online DDL, locking, deployment sequencing, rollback, data validation, change approval, and business communication. Question 7. What database security controls would you implement for sensitive financial data? I would enforce least privilege through role-based access, separate application, reporting, and administrative accounts, and prohibit shared credentials. Data would use encryption in transit and at rest, with keys managed separately and rotated under controlled procedures. I would mask sensitive fields in non-production, restrict network paths, record privileged activity, and review access periodically. Database auditing should detect unusual queries or exports while minimizing performance impact. Security controls must be tested, documented, and aligned with policy. Make sure to cover least privilege, role separation, authentication, encryption, key management, masking, auditing, privileged access, network controls, vulnerability management, and periodic access reviews. Question 8. How would you secure database credentials used by applications and administrators? I would avoid storing passwords in source code, scripts, or static configuration. Applications should use managed identities or a secrets vault that issues short-lived credentials where supported. Administrative access should require strong authentication, privileged access workflows, session recording, and separate named accounts. Rotation must be automated and tested so it does not interrupt services. Emergency access needs approval, time limits, and complete auditing. I would also scan repositories and deployment artifacts for leaked credentials. Discuss secret vaults, short-lived credentials, rotation, service identities, certificate authentication, separation of duties, emergency access, audit trails, and preventing secrets in code or configuration files. Question 9. Describe a disaster recovery strategy for a database supporting critical payment processing. I would define RTO and RPO with payment owners first, then choose replication accordingly. A standby in another failure domain would receive transaction changes continuously, with monitoring for lag and data integrity. The runbook would cover application dependencies, DNS or connection redirection, credential availability, message queues, and reconciliation after recovery. We would conduct planned and unplanned failover exercises, measure actual objectives, and improve gaps. Recovery is incomplete until balances and transactions are reconciled. While answering, cover RTO, RPO, replication topology, independent failure domains, transaction integrity, DNS or connection redirection, runbooks, dependency mapping, failover testing, and reconciliation. Question 10. How do you monitor database health and capacity before users experience an outage? I monitor service availability, transaction latency, throughput, error rates, connection usage, lock weights, CPU, memory, I/O latency, storage growth, and replication lag. Metrics need baselines and thresholds that reflect business impact rather than arbitrary numbers. I use dashboards for trends and alerts for actionable conditions, such as projected storage exhaustion or failing replication. Capacity reviews combine historical growth with planned business demand. Every alert should have an owner, runbook, and escalation path. Be sure to mention availability, latency, throughput, locks, replication lag, storage growth, connection pools, CPU, memory, I/O, error rates, baselines, dashboards, and actionable alert thresholds. Question 11. What is database normalization, and when might you deliberately denormalize? Normalization organizes data to reduce duplication and prevent insert, update, and delete anomalies. In transactional systems, it usually improves consistency and makes ownership clearer. I might denormalize when measured read latency, reporting joins, or a carefully defined access pattern justifies duplicated data. The duplication must have an authoritative source, refresh strategy, validation, and acceptable staleness. I would not denormalize preemptively. I would compare indexing, query tuning, caching, and materialized views first. Focus on reducing redundancy and anomalies, normal forms, transactional consistency, read performance, reporting workloads, materialized views, controlled duplication, and synchronization risks. Question 12. Explain transaction isolation levels and their impact on banking transactions. Isolation controls how one transaction sees changes made by others. Read committed prevents dirty reads, while repeatable read and serializable provide stronger guarantees, generally at higher contention or resource cost. Snapshot or MVCC approaches can reduce reader blocking but still require careful conflict handling. For financial operations, I choose the weakest level that preserves required invariants, enforce atomic updates, and test concurrency. Isolation alone is not enough. Application retries and consistent transaction boundaries also matter. In your answer, discuss dirty reads, non-repeatable reads, phantom reads, locking, MVCC, serialization, deadlocks, throughput, and selecting isolation based on financial correctness. Question 13. How would you troubleshoot replication lag between a primary database and its standby? I would distinguish transport lag from apply lag, then compare log generation, network throughput, standby I/O, CPU, and apply process status. Long transactions, bursts of redo, slow storage, or competing reporting queries are common causes. I would verify that no errors or gaps exist and estimate whether the standby can catch up safely. Remediation might include removing contention, increasing apply capacity, or temporarily reducing workload. I would never promote a lagging standby without quantifying potential data loss. Make sure to cover measuring lag types, network health, redo or log generation, standby apply rate, disk I/O, long transactions, resource contention, alerts, and safe remediation. Question 14. How would you migrate a large database with minimal downtime? For a large database, I would combine an initial bulk load with continuous change data capture to keep the target current. I would assess schema compatibility, sequences, extensions, permissions, jobs, and dependent applications first. Validation would compare row counts, checksums, key business totals, and performance. After rehearsing cutover, I would briefly quiesce writes, apply remaining changes, switch connections, and monitor closely. A rollback window and verified source preservation are essential if production behavior differs. Discuss assessment, compatibility, full load and change data capture, dual writes, validation, cutover rehearsal, rollback, application quiescence, performance testing, and communication. Question 15. What are the risks of connection pool misconfiguration, and how would you address them? A pool that is too large can exhaust database sessions, increase context switching, and worsen contention. One that is too small creates application queues and latency. I size pools using measured concurrency, database capacity, and workload class, rather than copying defaults. I enforce connection and transaction timeouts, validate connections after failover, and detect leaks through metrics. Each request must release connections reliably. Separate pools may protect critical transactions from reporting or batch traffic. In your answer, cover pool sizing, database connection limits, application concurrency, wait queues, connection leaks, timeouts, transaction cleanup, failover behavior, and workload-specific sizing. Question 16. How do you manage database patching and upgrades in a highly available production environment? I inventory versions and vulnerabilities, review vendor advisories, and test patches against representative schemas, drivers, jobs, and performance workloads. I take verified backups, confirm replication health, and use rolling upgrades when the platform supports them. The change plan includes pre-checks, connection draining, health validation, rollback criteria, and stakeholder communication. Afterward, I verify application transactions, monitoring, audit functions, and standby synchronization. I treat database upgrades as controlled releases, not routine server reboots. Be sure to mention vulnerability assessment, compatibility testing, rolling upgrades, backups, maintenance windows, replication checks, rollback, vendor guidance, validation, and stakeholder communication. Question 17. What is your approach to auditing database activity in a financial institution? I would audit authentication events, privilege changes, schema modifications, privileged commands, sensitive data access, exports, and failed attempts. Logs should be time synchronized, protected from alteration, forwarded to centralized monitoring, and retained according to policy. I would minimize unnecessary data capture to control privacy and performance impact, then define alerts for unusual access patterns. Periodic reviews should reconcile access with job responsibilities and preserve evidence for investigations, internal controls, and regulatory examinations. Focus on audit scope, privileged actions, authentication, sensitive data access, failed attempts, tamper resistance, retention, alerting, privacy, performance overhead, and audit review procedures. Question 18. How would you handle a database corruption incident? I would declare an incident, protect evidence, and prevent further writes if integrity is uncertain. I would run vendor-supported consistency checks, identify affected objects, review alerts and logs, and validate whether replicas are also compromised. If a clean standby exists, I would assess controlled failover. Otherwise, I would restore to a known good point and replay transactions carefully. I would communicate business impact and data confidence, then complete root cause analysis and strengthen prevention. Discuss incident containment, integrity checks, affected object identification, replica validation, evidence preservation, backup recovery, failover decisions, root cause analysis, and communication. Question 19. How do you prioritize competing database incidents and service requests? I prioritize by customer impact, transaction integrity, regulatory exposure, blast radius, and time sensitivity. A payment outage or potential data corruption outranks a performance request affecting a non-critical report. I acknowledge incidents quickly, establish an incident lead, communicate facts and next updates, and involve application, infrastructure, and security teams as needed. For routine work, I use documented service levels and risk-based change approval. Clear prioritization prevents urgent noise from displacing genuinely critical work. In your answer, cover customer and transaction impact, regulatory or financial risk, severity, blast radius, service level objectives, dependencies, escalation, communication, and documented prioritization. Question 20. Tell me about a database incident you resolved and what you learned from it. In one incident, transaction latency rose after a reporting job consumed database I/O during peak processing. I confirmed the pattern through wait events and workload metrics, then paused the job and protected capacity for transactional sessions. Service recovered, and I later moved reporting to a replica, added workload limits, and created alerts for I/O saturation. I documented the timeline, coordinated a blameless review, and measured improved peak latency. The lesson was to design isolation, not rely on operational discipline alone. Be sure to structure the response with situation, impact, diagnosis, actions, communication, recovery, root cause, measurable improvement, and a prevention lesson relevant to banking reliability. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.